All right, so 7-1, like I said, deals with symmetry. And remember, symmetry is sort of like if you cut something in half and both sides are equal. So we're going to be looking at 3 types of symmetry, though, when we look at graphs. So, y'all, the first type of symmetry we look at is what we call symmetric to the y-axis. So, if a graph is symmetric to the y-axis, you can take the graph and fold it over the y-axis and it'll land on itself. So, folding the graph over the y-axis and the graph lands on itself. Okay. It's almost like that. The y-axis is sort of cutting it in half. Okay. Now, if a graph is symmetric to the y-axis, so if a graph is symmetric to the y-axis, it is what we call an even function. Okay, so that means usually graphs that makes something that's symmetric to the y-axis, they're going to have even exponents. So that's what they mean by even function there. So let me give you an example of a graph symmetric to the y-axis. And we've been doing a lot about parabolas. So y'all, this little graph of this parabola. Right here, if I took the right side of my graph, folded it over the y-axis, this right side would land exactly on the left side, okay? So that's what we're looking at when we're talking about symmetric to that y-axis there. So then the second one would be symmetric to the x-axis. And I check it the same way, but instead of folding the graph over the y-axis, we will fold the graph over the x-axis. So folding the graph over the x-axis and the graph lands on itself. All righty. So we'll be taking them from the top and folding them over the x-axis, okay? If it lands on itself, then it is symmetric to the x. So let me show you an example of that. So I could have a function that sort of does sideways. But notice if I took this graph and I folded it over that x-axis, this top part right here will land exactly on that bottom part. Now notice, I told you that this up here, when it's symmetric to the y-axis, is an even function. Well, y'all, this graph, it's not the one that's going to be odd. Because remember, this is not even a function because these x's have 2 y values for them, okay? So this would fail the vertical line test. That's why it's not an even or an odd function. It's not even a function if you get this graph, okay? All right, but this third type will be the odd one. And this is what we call symmetric to the origin. Now this one, the origin is the center of a graph here. So if it's symmetric to the origin, the way we check that, we're going to turn. So turning the graph 180 degrees or upside down. So if I turn the graph 180 degrees, I'll turn it over, okay? Now, turning the graph 180 degrees, and we get the same picture. Or how about the same graph? So that means the graph looks like it did in the normal view. When I turn it upside down, if it looks the same, then it's going to be symmetric to the origin there, okay? Now, if it's symmetric to the origin, it is a odd function. That's because graphs that are symmetric to the origin have odd exponents, okay? So a graph that would be symmetric to my origin, I'll do a cube. So a cube will come in, sort of passes through the center and goes uphill. Now, notice this graph is going uphill, left to right. If I was to turn it 180 degrees, I still got a graph that's going uphill from the left to the right. Okay. So that's what we're talking about. When I turn it upside down, I got the same picture, and that's what's making it symmetric to the origin. Also, another thing, I'm going to do these in MATLAB so y'all can sort of see what the problems will be like in there. So they'll ask us, what is it symmetric to, the Y, the X, or the origin? And then the last two talk about even and odd. Remember, if it's even, it's symmetric to the Y. If it's odd, it'll be symmetric to that origin there, okay? So y'all, let me switch to MATLAB so we can look at these 5 problems here. And I'm going to make that larger. So y'all should be seeing my number 1 now. So it says, determine if this graph is symmetric with respect to the x-axis, the y-axis, or the origin. All right, y'all, so notice if I take that graph and fold it over the y-axis, the right side will not land on the left side. So it's not symmetric to the y-axis. If I was to fold it over the x-axis, the top of this graph will not land on itself when I fold it over to x. But notice, if I took this picture and turned it upside down, the part that's on the bottom right will end up on the top left and vice versa, which would result in the same graph. Okay, so that graph would look the same either way I turned it. So that graph is only symmetric to the origin. All right, y'all with me on that? All right, y'all, so I'm gonna make this one larger here. All right, so this one's for y'all. Determine visually whether this graph is symmetric to the x-axis, y-axis, or the origin. What are you going with on number 2? Right now, I see my chat popping up. Let's see. Chad is saying y-axis.
Y-axis.
It's definitely the y-axis. If I take that graph and fold it over that y, that top part of that is, the right side will definitely land on the left side. So it is definitely the y-axis. All right, y'all, you would check that. Next question. Let me make this one a little larger. And we almost did one like that on my examples. So this one asks you one at a time. First off, is this graph symmetric to the x-axis? Yes or no?
No. No.
Oh, okay, now check this out. You see that x-axis there? Can you fold?
Oh, yeah.
See how it sort of folds on top of each other? It looks like the chat's hitting them up all. Yeah, that top half on that, and if I fold it over, it will definitely land on the bottom half. So it's definitely symmetric to my x-axis. Now, but watch it. Just want to go through this. Is it symmetric to the y-axis there? So the y-axis is your vertical axis. And let's see, Chad, y'all were saying no on that one. Good job. If I fold it over the y-axis, it'll just be on the other side, but it's not landing on itself. So notice when it was symmetric to the x-axis, that x-axis cut it in half. So that's what's happening with these x and y axes. If they cut it in half, then you know you got something there, okay? So y'all said no on this one. So now, if you turn this page 180 degrees, will this graph look the same? Which means, is it symmetric to the origin?
No.
No. If I turn it 180 degrees, it won't look like less than looking like that. It'll turn the other way and look like a greater than. So that picture will not look the same. And let's see, chat, y'all are saying no also. Good job. So that would be no on that one. Then you would check that. These homework assignments, it's only going to be one or the other. I can show you a graph that would be toward a symmetric to all of them. Well, let me see, Kimbrough. All righty, so let's see. We got a graph here. Looks like an upside down U. But they want to know if this thing is even, odd, or neither. So remember, even is going to be symmetric to the y-axis. And an even function will touch the x-axis an even number of times. If it's odd, it's symmetric to the origin. And that means it would touch the x-axis an odd number of times. So y'all, are y'all going with odd, even, or neither?
Odd.
Okay, let me see what y'all are saying.
Even.
So y'all
Even.
y'all are
Would it
saying
be
even? Even. Good job, y'all. Because see, it's symmetric to the y-axis. That y-axis sort of cuts it in half, which makes it symmetric to the y, and we said those were even functions. And then count how many times it's touching the x-axis there. It looks like it's touching twice, which is also even number, okay? All right, let me make this one a little larger. So, is that function almost looks like what we call a sine wave, even, odd, or neither. And let's see, chat, y'all hit fast. Y'all are saying odd. Perfect. It is definitely odd. If I took that picture of that graph and turned it 180 degrees or upside down, you're going to have the same picture. The top part right would be on the bottom left and vice versa. Also, let's see, that touches 1, 2, 3. It touches the x-axis 5 times. So y'all, that is definitely an odd function, okay? So we check that and then be done. So y'all, that was 7-1. You got 5 problems. And it's just looking at a little symmetry there, okay? All righty. 7-2 is a little bit trickier than 7-1 was. But 7-2, we're looking at transformations. So transformations we're going to see how to move a graph up, what would make a graph move down, how can I make a graph move right, how can I move a graph left, and then I'll reflect a graph over the x-axis here. So before we look at the 3 types of transformations, we're going to look at what we call basic graphs. Because these are going to be the graphs that we move around, okay? And I got 6 basic graphs we're going to look at in this section. So the first one is the x squared graph, y equals x squared. That graph is the parabola that touches the x-axis at 0, okay? And y'all have graphed a lot of x squared graphs to know that now they're the parabolas. Second is a graph that cuts right through the center, almost like a 45-degree angle. It cuts right through there. This is the y equals x graph, the straight line. Now, if you throw a slope, the slope of this would be 1, right? Because there's not a number here. So remember, up 1 over 1, up 1 over 1. Now, if you add a y-intercept and all that, it moves the graph around. But this is the basic line graph. All right, next. We got the cubes. The cubes come up, pass through the center, and go uphill. So this would be the y equals x cubed graphs, okay? All right, y'all, so 3 more that they mess with in this section. This is a square root graph, and a square root graph sort of goes uphill to the right. Oh, yeah, that's all right, Faith. I figured we'd have quite a few people getting knocked on and off because of that, whatever happened to them phones today. All right, y'all, this one is the square root of x. Now, notice the square root of x graph only goes to the right side of the y-axis. That's because we can't take square roots of negative numbers, remember? So this graph won't go to the left side. Because remember, when you try to take square roots of negative numbers, that's where y'all got those imaginary numbers from. So the square root only goes to the right. All right, this one is a cube root. Now, cube root sort of looks to the right, like the square root, but it's not as steep. But you can take square roots of negative numbers, so it'll shoot down to the left also. Remember, I can take cube roots of negatives, but I cannot take square roots of negatives, okay? So this is the cube root of x. And then we got one more we call a reciprocal graph. So this graph on the left side comes in and then it heads straight down. On the right side, this one's coming in from the top and then it sort of wants to head towards the x-axis in both directions. This is the reciprocal y equals 1 over x. Now, you'll learn later. You see how this graph does not cross over the y-axis? This side goes up forever and ever, never crosses it. This side will go down forever, never crosses it. How come this graph cannot cross the y-axis? Well, y'all remember, we've been playing with the domain all week. Can you put a 0 into that x? No. If you put a 0 in here, it makes it undefined, right? Exactly, Caitlin. So we'll learn later on in life that we call those vertical asymptotes, and that's a place where the graph cannot cross, okay? All righty, so these basic graphs, because when you graph your answers, you got to know which shape to pick. For the x squared, you pick the parabola tool. For the cubes, you're going to pick the little squiggly line. For the lines, remember the line tool has the line with 2 points on it. Usually these ones here, for the most part, they'll draw those for us. The ones we actually move will be like these 3 here. So let's look at the 3 transformations. Three transformations, and then we'll start. I'll show you how in the math lab to move those graphs around, okay? So the first transformation we do is a vertical shift. A vertical shift will be either up or down. So for a graph to be moved up or down, it'll be in this form. Y equals f of x plus or minus some number. So f of x would be the x squared, the x cubed. Okay, so we're taking x squared, say, and we're adding a number to it, or we're taking the x squared graph and we're subtracting. So here's the thing. If this b is positive, if b is positive, your graph will move up b units. Okay. If the b is negative, then, so I got, say, x squared minus 3. If I have a minus, then it's going to move my graph down b units. So let's do an example of this transformation here. So say I had, these will say describe how to graph can be obtained by one of the basic graphs. Okay, so this one they're giving me f of x equals x to the third minus 4. So first of all, y'all, we got to figure out which one of these 6 basic graphs they started with. Well, you see an x to the third here. I got an x to the third graph up here. So that means we start with the basic graph. Of y equals x to the third. Now, we shift the graph. Well, y'all, what is that minus 4 doing to my graph? If I got a negative 4 attached to the end of my function. We've got 2 choices. It's either going up or down. So since this is my negative b, oh, I didn't see my chat lighting up, y'all. Let me see. So good job. It's definitely going down. That's a negative 4. So it's going to shift the graph down 4 units. Now, I won't graph them here yet. I'm going to show you how to graph them when we get to the math lab part of this. But remember, you start with the basic graph of the cube, and that minus 4 moves it down 4 units, okay? If that was a plus 4, it would have moved my graph up 4. All righty. Our next shift is a horizontal shift. All right, let me let one in real quick. Oh, y'all must be just getting knocked off today. All righty, second for transformation. This is a horizontal shift. So horizontal will be either left or right, okay? So left or right. So to make my graph move left or right, will be in this form. Y equals f of x plus or minus a. Now notice, this is not the same as the vertical. The vertical, I had my function and I added a number at the end. This is changing the x values before they get evaluated by the function. So here's the thing about this one. If this a is positive, so if the a is positive, it actually moves the graph left. It moves left a units. So if I add to my x before it is evaluated, it moves me left. And then if that a is negative, then it's going to move it right a units. And so let me do an example of that one. So y'all, the same thing. Describe how to graph. Can be obtained by one of the basic graphs. And I'm going to play with that cube again so that y'all see the difference. So this time they're giving me y equals x minus 4 cubed. Now remember, while while ago, for the vertical, I had x cubed minus 4. But notice, this 4 is now inside the parentheses with the x. So you're evaluating that before you cube it. That's what's forcing it to go left or right. So on this one, we would start with the graph y equals, well, still the cube graph because you got your exponent 3. So it's still going to be the cube graph, but now we're going to shift the graph. Now remember, that's negative a being added. We said if it's negative, it moves it right. So this will shift the graph right 4 units. Okay, so you got to get used to, am I attacking the x inside parentheses, or is it just a number added or subtracted at the end of the function, okay? Alrighty, y'all. So then we got the third move. And the third move is what we call a reflection. And the only reflection we're doing in this chapter is we're going to reflect over the x-axis. So if you choose y-axis on the homework problems, you'll mark it wrong because we're only reflecting over the x. Okay. Now, to reflect the graph over the x, I'll have something like y equals negative f of x. So what this negative does, if all your y values were positive, by putting that negative in the front, it's going to take all them positive numbers and throw them down to the negative side. So it's going to take your graphs and it basically flips them over the x-axis, okay? So on this one, if I was going to do an example, so the same thing, describe how the graph can be obtained by one of the basic graphs. So they're giving me, and I'm going to play with the x cubed still, but this time they're giving me y equals negative x cubed. So notice I took the x cubed graph and we moved it up or down a while ago. We moved it left or right. Now, by throwing that negative in the front, we're reflecting it. So you would start with the graph of y equals x to the third, and then reflect it over the x-axis. Okay, now I'm going to go through and do the homework problems for you for this section so that you can see what tools to use and what's really happening on these things, okay? Because as we graph them, when we're doing the moves, you can actually see the graphs move in MATLAB, okay? So this will be 7-2, so let me share that. All right, so y'all should be seeing my first question in 7-2. And it says, describe how the function can be obtained from one of the basic graphs. And they got y equals x plus 9 in parentheses, then being squared. So what you got to figure out first is, Because notice A, B, C, D, the only difference is, are we shifting it right, up, left, or down? Well, remember, it's inside the parentheses with the X. When it's inside the parentheses with the X, it's either going to go left or right. And y'all, we said, well, if you added to the X, it would move you left. So you have to go down here to C and click C because that's the one that went left. And then the only basic graph that could be, you see that exponent of 2 there. So that tells me that I got the X squared graph. So you tell it what moved first, okay? Now, you're going to check that answer. Then you're going to come back in here, and down here, I'm going to click to enlarge the graph. All righty. That's the X squared graph. You're going to go to the second row and use the U-shaped X squared tool. Now, here's the thing. We don't have to plot points. All we do is grab that tool and then click anywhere on your graph you want. You can click anywhere. It'll draw the parabola right in the middle like a basic graph, okay? Now, to move it, you see it opened up this little box on the right side. Now, y'all, do not worry about the vertical stretch and shrink or the horizontal stretch and shrink. We're not messing with those in this chapter. We're either going to mess with the vertical shift, horizontal shift, or we're going to reflect it over the x-axis. So that one went left 9, so that is a horizontal shift. So come down here and drag that little gray box left to -9. Once you've got it on -9, look at the graph. It just moved left 9 units. Save it, and then you're going to check it. Now, this one for number 2, y'all, x minus 8. When you graph this one, you physically got to plot 2 points on this one, okay? Because it don't have a shape other than the line tool, and on this line tool, we got to plot 2 points. But this is the pretty much the y equals x graph. What we got to do is figure out what that -8 is doing to this graph. Now, it's not in parentheses. So since it's not in parentheses and it's just thrown at the end of this function, you're either going up or down. Well, we said if it was negative at the end, it would go down. So this will be B no matter what. Shifting it down 8 units. And remember, we're starting with the graph of y equals x. It's always going to be one of them 6 basic graphs, okay? So I said I start with y equals x, shift it down 8 units, check that answer. And then it's going to make us graph it. So I'm going to click to enlarge my graph. All right, remember, that's a straight line. So we use the second tool on the top that says line tool. And now I need 2 points. So y'all, on that point, let me share my other screen real quick. So remember, I had y equals x minus 8. So remember, to plot that, I need 2 points real quick. So you can use 0, 1, 2, 3. It don't matter what numbers you use. I always use pretty much 0s and 1s. So 0 minus 8 makes that a -8 for that y. You put a 1 in. 1 minus 8 makes that a -7. I'm going to go plot these 2 points. So let me go back to the math lab. So I got my line tool. So 0, -8 will be at the middle, go down 8. Ooh, this is tricky for my fingers to get on these numbers. And then 1, -7 will be right 1, down 7. All right, I think I'm there. All right, y'all. On this one, all you do is plot the 2 points. It's already moved the graph down for you. This one don't open slide controls and all that. So on it, you just plot your 2 points. You see that the line did move down. Save that. Check your answer. All righty. So this is that one graph I called the 1 over x. So we call that the reciprocal graph, which is 1 over x. And they're even telling you, hey, you're starting with the graph of 1 over x. What is that plus 2 doing to this graph? So what do you think? Is it in parentheses with the x, or is it just thrown at the end? Will that move me down, right, left, or up? Oh, y'all letting me get you on that one.
Is
All
it
right.
down?
There's my chat. It's starting to come up.
We go
Down?
up.
Okay, so I'm getting downs and I'm getting the ups. So let's think. Let me show y'all something. Let me pull me a page. Now remember, that's a 1 over x plus 2, okay? All right, let me pull this up. Can't be this one because we're doing inside the parentheses here. Well, we're not inside parentheses. We just got a 1 over x plus a 2 at the end. So it looks like this. You got your function plus your number. Well, y'all right here, we said if that was a positive number, that thing is going up. Okay. So it went up. So you're going to go back here to the math lab. Also, another way you can do this is graph it on your calculator and actually see what happens. Go to y equals and put 1 over x plus 2, and you'll see that that graph actually did go up 2 units. Now, they don't make you graph this one, but you got to pick which picture it is. So A, B, or C, which one went up? And I'll tell you
A.
what, which one?
A. Wait, no. No, B.
B, there you go. Because A is technically the basic graph, remember? Right? A is the basic graph, the 1 over x that we drew. But B, you see how everything sort of shifted up a little bit? So you would choose B on that one. And then C looks like they went down. All right, look what you got here. Negative x plus 2 to the third. That plus 2 is now inside the parentheses. So we need to know that plus 2, is it going to shift me right 2 units or left 2 units? And that's the only 2 choices they give you on that. A and B are both going right 2 units. C and D are both going left 2 units. So y'all, that's like the A. And if the A is positive, which way you going?
If the A is positive, you go up. So you'll go down on this one, all right?
Oh, where y'all at? Oh, all right. So let me get y'all back to my page now. So let me show y'all what's happening here. Notice we now have a, it was in parentheses. Well, look here. Here's the one that's in the parentheses. So remember, if the number's in parentheses, if the number's in parentheses, you're using a horizontal shift. And that was a plus. Look, right here it says if the A is positive, we're moving left. So y'all, let's go back and see what we got. So that is a positive 2. So it's definitely going left 2 units. It's either C or D. Well, That negative in the front, is it reflecting me over the y-axis or the x-axis?
The Y?
Oh, what y'all just say?
Would it be the Y-axis since it's negative?
Well, let me see here. I only gave y'all one, member, so let me go back to that note. And look here, the only axis we reflected over was the
The
X-axis.
X-axis.
x-axis, okay? So do not pick y-axis on this at all. Because we're not flipping nothing over the y-axis, okay? So that means we went 2 units left because of the positive 2. We reflected over the x because of the negative in front. So y'all would check that. Now, the basic graph I start with, well, I see an exponent 3 out there. So that means this would be a x to the third. And then we check that answer. Now let's graph this. So I click to enlarge my graph. So that is a cube. Exponent 3, you're going to go to the second row of tools over here and pick the second one that says the X cube tool. Y'all click it, click anywhere on the graph. It's going to put it in the middle. We had 2 things happening. That plus 2, we said move this left 2 units. So go down to the horizontal and move that left 2 units to -2. Then we reflected it over the x-axis. And if you watch my graph, when I click this reflection, watch what it does. Instead of the graph going uphill, it's going to flip it over so that it goes downhill left to right. So then you would save that and check your answer. All right, y'all, I'm doing 4 again. This is for y'all, okay? I'm
Thank
giving
you.
y'all a negative parentheses x minus 9 to the cubed, third power. So the same type graph, but are y'all picking A, B, C, or D?
D? Well, hold on. Let me see yours. Right.
Well, y'all can eliminate A and C.
Yeah, it's gonna be 9. I mean, it's gonna be D.
D, so, oh, look at you go, because that -9 moved it right. Good job. And then you're reflecting it across the X. Good job. Now I won't graph it. I just wanted to see what y'all would do on that. And then it's still what the X to the third. Okay, y'all. So just get good. If it's in parentheses, it's left or right. And it's sort of backwards what you think. Now, if it's added at the end, not in the parentheses, it's up or down. And that's pretty much, I would think, positive up and negative down on that, okay? So just play with those. Let's see what 5 has here.
If we were to graph that one though,
Okay, so let me go back. Oh, it changed it. So pick A, B, C, or D real quick, and we'll graph this one.
we'll see
Just
that's gonna make it different.
uh-huh.
Um,
Now, yeah, I'll graph
would it
that
be
one.
C?
So let's see what you got here.
Would it be C?
So the +3
Oh, I mean to the left.
is okay.
So it
Good
would
job. It's
be
left
it would be A.
A because it's going to reflect it over the X, and then it's still the X to the third. All right, so let's graph this one. I guess it changes my problem every time I get off of here.
Question, could you do like a mock draft? I mean like a mock graph of the X minus 9 one on here?
Yeah, I'll do the X minus 9 first. So
Okay.
that was a negative and then X minus 9 cubed. So if we was graphing that one, all of these on this number 4 are going to use the cube tool. So click the X cube tool and then click on your graph. So we'll all start in the center. So that was what? -9 on my graph. So we said it moved it right 9. So go down to the horizontal shift and move that to a +9. So see, it moved me right 9. And then go down here and click the box that says reflect over the x-axis. At that point, it has flipped my graph. I would save that and then check it. Now that'll be wrong on this one for me because I changed my problem, but that would be the one that had the x -9, okay?
Okay.
Yeah, so that's all you got to watch out for is look at this one. Here we go. This one's a nice one. X plus 2 squared plus 1. So y'all, what graph would we start with first? Out of them 6 basic graphs.
Y equals x squared.
X squared, perfect. So let me put in my X and we'll square that. Now it says shifted blank 2 units. The 2 is inside the parentheses. It's positive. Is that going right, up, down, or left?
Up.
All right, y'all are inside those parentheses, though. All right, so let me
You're
fix.
gonna go to the left, aren't
I
you?
think I can fix y'all real quick. All righty, so
Are you gonna go to the left?
oh, I'm going to go left. Perfect.
Yeah, left.
But let me. So
I'm
here's
sorry,
the
my
thing.
computer is like in and out due to the AT&T thing.
So I'm going to show y'all real quick. So say I had a negative and then an X plus 5 and then say a -7. The only thing that negative is going to do right there is reflect over the X. This here, it's inside the parentheses. The only choice it has is to go left or right. Now, since this one's positive, it would actually go left for me, right? And then the number at the end, the only thing this number can do is go up or down. Now, since mine's negative, it'll actually go down on it. So remember, these are the moves. No matter what function I put here, it could be a cube. It could be a square. It can start with any of them basic graphs. But if it's inside parentheses, left or right, if it's at the end of the function, it'll be up or down. So you got to think about these parentheses, okay? So let's go back to that one. Because look, I got a number in parentheses and outside those parentheses. And was it Jerry? I think you said it, right? Or someone said a while ago that we're going to go, that +2 is going to make me go
Left.
left. Now at the end is a +1. What's that +1 at the end going to do? Well, it's either going up, left, right, or down.
Going up.
It's going up. There you go. Okay, so you gotta, y'all, your main thing is you gotta look at are the numbers in parentheses with the X's, okay? Or are they just thrown at the end of my function? So you check that. Now we know we're going to have to graph it, so we're going to click to enlarge. Remember, exponent 2, that is the x squared graph. So you're starting with that x squared tool again, and then click anywhere. It's going to put it in the center. So the +2, y'all said moved it left 2. So come to your horizontal and move that horizontal to -2. Then the +1, y'all said, went up 1. So take the vertical shift and go to the right, up 1. Notice, y'all, the graph moved left a little bit, and it moved up a little bit. So at that point, save that, and you would check your answer.
Question
I hear you.
before you move on. So what if we have a +3 and then a -1?
So +3 inside the parentheses.
And a -1 outside the parentheses.
+3 inside the parentheses is going to move me left 3 because it's inside the parentheses and it's positive. So that went left 3. And then, y'all, what's that -1 at the end doing?
Going down.
Going down. There you go. Right. Then you're all, and then I don't know what graph it started with. Mine was a square. It might have gave you a square on that one too, did it?
Mm-hmm.
Okay. All right, let me write this one down because I want to show y'all something about this. This is f of x equals a square root x minus 10. Now, I want to show y'all something about this problem real quick on these radicals. On these square roots like this, if it's under the square root radical like that, you would definitely treat it like it was in parentheses, okay? Now, if you had f of x equals square root of x minus 10, if the 10 was not under the radical, then this would be up or down. But this one is under the radical with the x. So you treat it like it's in parentheses, which means this is going to go left or right. To go up or down, that 10 would have to be outside the radical, okay? So you always treat square roots like parentheses, even in order of operations. So now that we know that, we're starting with this graph of square root of x. Is that -10 under that radical inside those imaginable, whatever you call it, parentheses? What's that thing going to do?
Left or right, right?
It's going to go right. There you go. So we would click right, throw in our 10, because you actually got to say, okay, right, 10 units. So you check that one. Now, this one will have pictures we check out of or we choose from. So let's see. Let's make these a little bigger. Did A go right, B go right, C go right, or D go right? And if you remember, your square root of graph started right in the center of that graph. So which one of these A, B, C, D are we picking that went right 10 units? So y'all, I'm looking, A looks like it went up. So A definitely went up. Well, look at B.
Is it?
Yeah, because it should start in the center, but it's over there starting at that 10 now. So B went right. C went down.
It's gonna be C.
And then D went left, right? So the only one would be the B, right? So check that.
Yeah.
Now, knowing what I just showed y'all on that paper, that -3 is not up under that cube root radical. So is that -3 going to move me left, down, up, or right? And remember, the -3,
Oh, wait. Would it be down since it's not in the parentheses?
it'll be down since it's not in the parentheses. Perfect. So we would go with B on that one, y'all. Okay. And then let's see. We're going to have to graph it. So which one of these cube roots, let me make these a little bigger. Well, which went down, A, B, or C? And I will say that B looks like the basic graph we drew. So if B is the basic graph, who went down, A or C over here?
Would it be A?
It'll be A, perfect. Because A, that whole graph just sort of went down 3 units, it said. So then you're going to check that. All right, let me plop on and see what it does on this one. All right, y'all, I'm going to do that one again just to see what y'all do on your own. You got a g of x equals the cube root of x plus 3. A, B, C, or D?
D.
All right, let me catch up with that chat. It's popping up. So D, perfect, everybody. Good job. So D, because it went up. And now remember, you're going to have pictures here. All right, so let me see what y'all are saying. A looks good because it's the only one that went up. Looks like B went down, and then C would be the basic graph. So good job. Choose A on that one and do your final check. I don't think it'll be too bad once. That's why I play with these a lot on these problems, just to get y'all into the what's happening here. This is a good one to see what's happening. Check this out. We're starting with x squared graph. Well, we know that. We see that little exponent 2 there. So the first move would be the x minus 7 because they sort of follow order of operations. So that x minus 7, is that moving me right 3, left 7, or right 7? And there's no up and downs, so it's got to be either right or left. So you're subtracting that 7, remember?
Would it
Left.
be left?
Oh, I think I heard one of each. Let me see
Left?
what.
Left. Left, right. I mean, like
Oh, y'all are
left.
letting me get y'all.
Left 7.
Well, remember,
Oh, right 7 because it's negative.
it's negative. It's got to go right. Remember, the ones inside the parentheses, y'all, are backwards from what you think. You think minus 7 is going to move that one left, but it definitely don't. It's going to move it right 7. The parentheses are backwards from what you think. Now, reflected across the y or x axis.
X.
Yep. You got to say x every time, y'all. That's the only one we're doing. Now, shift it up 7, down 3, or up 3 units.
Up.
I'm going to go up and let's see what the chat says. So up 3, good job. That definitely is up 3. All right, check that. Now, 8's the last one, so let me switch to another number and then come back to 8 because I want y'all to play with this one. All right, there you go, y'all. Y'all got negative x minus 6 squared plus 4. It says start with h of x equals x squared, which is our basic graph. And then you're going to shift it right 4, left 6, or right 6.
Mm. Is
All right,
it
so
going to be,
Gonna be
isn't it going to be right?
Right 6.
okay, I'll take that, right 6. Just remember, y'all did good. Parentheses are a little backwards from what we think, but definitely going to go right 6. Reflected across the
X axis.
x-axis. And then shift it up 4, down 6, up 6.
Up 4.
Up 4.
Up 4.
There you go. Y'all, that's the trick. And And I like doing this one because it sort of lets you focus in on, am I in those parentheses or am I sort of out of those parentheses, okay? All right, y'all, so that's all you got for 7-1 and 7-2 is doing a little bit of symmetry in 7-1, and then 7-2, moving some graphs around, okay? Now notice, we didn't have to physically graph, but the second one that had the line. All the rest, you'll either pick a picture or choose the tool and move it with that little box that pops open, okay?
Can you do me a favor?
Okay.
Can you go back to section 7.1 just because I came in a little late on that one? I came in on the last two questions.
So let me show
Um,
you. We can do that real quick right here.
Yeah.
You came in on the,
The last two where we were doing even and odd. So, the
okay, so let me,
first,
I'm trying to get back to that. And
yeah, the first one is
so let me
asking
go to number,
about,
are y'all
yeah.
seeing my, are y'all seeing
Mhm.
my 7-1 now?
Mhm.
Is it showing 7-1?
Yeah.
Okay. So there's three symmetries. The x-axis, to be symmetric to this x-axis here, the x-axis basically has to cut the graph in half. And if I fold that graph over the x-axis and it lands on itself, it's symmetric to the x. Now this one, if I fold it over the x-axis, that little hump is not going to land on a hump on the bottom of the x. So this one won't land on itself. So let me find something. Where am I at? I'm going to go to my page real quick and show you something. So right here, symmetric to the y-axis. See, the y-axis cuts it in half. And if I take this left side and fold over the y-axis, it lands right on itself. So the y-axis cuts it in half to be symmetric to the y. And the x-axis is the same thing. The x-axis cuts its graph in half. And if I took the top of this graph and folded over, this top would land exactly on that bottom. And the x-axis sort of divides it. So if it's symmetric to the y divides it. Symmetric to the x divides it. Then there was the third one. We said symmetric to the origin here, which is the center. You see how this graph goes uphill left to right? That says if I can turn this 180 and I get the same graph going uphill left to right, it'll be symmetric to the origin. So watch my graph going uphill. I'm turning it 180 and look at my graph. Same graph going uphill left to right. If it does that, then it's symmetric to the origin. Also, I said if it was even function, if it's symmetric to the y, and it was an odd function if it's symmetric to that origin there, okay? So let's go look at that number one again. Knowing that, let me make that a little bigger. Well, look here. It's not symmetric to the y-axis because the y-axis don't cut it into two even sides. And if I fold it over to y, this hump will land over here where there ain't no graph at. So then I look at the origin. So if I took that graph and turned it upside down 180 degrees, I would have the same graph, wouldn't I? This part that's on the bottom right side would end up on the top left. And this part of the graph on the top left would end up on the bottom right. So it is symmetric to the origin. And then just looking at the x, well, the x doesn't cut it into two equal parts. Down here, if I was to fold it over to x, it's not landing on itself. Okay, so that one's only symmetric to the origin. All right, let me make this one bigger. All right, so knowing what I just told you, what do you think about this graph? Is this graph symmetric to both the x and y, the origin, the y-axis or the x-axis?
The Y.
The y. So it cuts it right in half into two even parts, and if you fold that thing over, it's going to land on. So good job. And then let's try one more with you. All right, make that a little bigger. So what do you think about that one? Is that symmetric to the x-axis?
Yes.
Okay, so this one will make you go through and ask you all of them. So yes for the x.
Mm-hmm.
Is it symmetric to the y-axis?
Yeah. Wait, yes.
Uh-oh, check it out now. Remember, the y-axis is vertical. If you took that right half and folded over that y-axis, it
Would
don't
it not?
land on, it don't land on itself, does it? See, all this part up here would be over here up where my cursor's moving, but it's
Oh
not.
no.
Okay, good
No.
job. Good job.
Okay, I'm sorry.
Good job. And it don't turn it in it ain't cutting it in half. That y-axis is just cutting it like a little bit off of it, but not in half.
Mm-hmm.
All right. Now let's see. Is it symmetric to the origin? If you turn it upside down where you had the same picture, well, this
No.
looks like a less than, right?
Uh-huh.
If you turn that upside down, it'll look like a greater than. The wide part will be left and the pointy part will be to the right, but it ain't going to look like the same picture. So since it won't look like the same picture, that would be a no. You'll see it's only going to be symmetric to one of the three in this section, okay? Now, I guess everybody's number one is a little squiggly line like this, right?
Mm-hmm.
All right, so is that symmetric to the origin, y-axis, or x?
I think I put the X. No. Would it be the origin?
It'll be the origin. Good job. See, it sort of goes downhill, uphill, downhill. If you turn it 180 degrees, it'll still go downhill, uphill, and downhill, okay? So that was the trick on those first few problems, was just looking at the symmetry. And that's basically what I was doing on 4 and 5 on that one. If it was symmetric to that y-axis there, I knew it was even. And if it was where I had the origin and I had to sort of flip my pictures, then I knew it was symmetric to my origin, okay? But y'all, they're not too bad. You just gotta sort of play with them. Get used to 7-2. Is those numbers inside the parentheses or are they outside those parentheses, okay? If they even have parentheses.